go. All right, hey, Jake Hodson, this is 10-2, areas of trapezoids, rhombuses, and kites. There is one formula that we have for trapezoids, and then there is two that we have for rhombus and kite because they're the same one. Okay, so this is what a trapezoid looks like. When we were doing parallelograms, we had area equals base times height, yes?
Yeah.
Now, it's the same for a trapezoid, except my height is just going to be the height, right, for a trapezoid, but for a trapezoid, I have two different bases. So it's like, okay, which base do I use?
Average.
Do I use the top one or the bottom one? I use the average. How do you find the average of the two bases? So I take base 1 plus base 2, and I divide by 2. That is the base. So rather than having one number as the base, we take the average. And then we take that times the height. Okay? Now, I'm going to write that down here in this little box, because that's not the way that they write the formula. So base 1 plus base 2 divided by 2, that's like the average of the two bases times the height, right? That's what we got. This is how they write that same formula. How does that work?
What?
They're just taking half.
Yeah, rather than dividing by 2, they'd multiply it by a half, which is the same thing, right? So you can use either formula. You can either take the average of the bases times the height, or 1/2 height base 1 plus base 2. Either way, okay? So those two mean the same thing, but that's what you're doing. You're just doing base times height, but it's the average of the bases, okay? So down in this thing, we're finding the area of this, and we take 1/2 of the height. What's the height? 30. And base 1 plus base 2, so 28 plus 58. This morning, Kyle multiplied 28 and 58 together. Don't do that. Okay, 28 plus 58 is 86. Half of 30 is 15, so 15 times 86, whatever that is.
What?
15 and 86, or whatever you got, the whole thing.
1,290.
1290. Yes, that's correct, because that's what we got this morning. Centimeters squared, because it's area. Okay, half the height times base 1 plus base 2. Okay, this one's a little bit harder because we have things that we may not be given. So here's the area. We still have 1/2 height base 1 plus base 2. Okay, so in this trapezoid, what's the height? Or what are my two bases? Let's do the bases first. What's my bases? Yeah, this is like setting up on like its height actually. So those are my two bases, right? The height is, what do you say? 4. So 1/2 times 4. Whoop. 4 goes in this spot. And then one of my bases is 10, but I don't know this other one. So we gotta do a little bit of work. Okay? All right. So you gotta watch this because this is a little bit far-fetched and it's like kind of confusing. Okay? Do you see this triangle right here?
Yeah.
I'm going to lump the triangle off of the little rectangle that's on the bottom, okay? The dimensions of this rectangle down here, right? We're trying to find this side, which is the same as this side, correct?
Mm-hmm.
Okay? So if we knew what this was, we could subtract it from 10 to find this, which ultimately gives us that, right? Are we lost yet? Yeah? So we can do the Pythagorean theorem for this triangle, right? This is 8.5. What's the bottom side? 4, right? So the Pythagorean theorem, we'll call this guy x, right? So x squared plus 4 squared equals 8.5 squared. Okay, this is 16. 8.5 squared, I don't know what that is. 8.5 squared is 72.25. Yep. Okay, then what? Subtract the 16. And then, whoop, 56.25. So x squared equals 56.25. And then you take the square root, which is 7.5. Okay, so are we lost yet? Are we doing okay? 7.5 is that guy. What did that help us find? This little piece right here, which is 2.5, because they all add up to be 10. I kind of like hid that. So this is 2.5, and that's the other base, right? Okay, so what's 10 plus 2.5? 12.5. What's half of 4? 2. What's 2 times 12.5? 25. And that is in inches squared. Not too bad, right? Okay. Okay, let's go to rhombus and kite. A rhombus is a tilted square because all of these sides are exactly the same. You remember studying rhombus, right? Okay. Is a tilted square. And then a kite looks like a kite, like it has one edge that's longer. Okay. We're finding the area of both of these. but they're the same formula. So let me show you. Just watch for just a second and I'll show you how the formula comes about, okay? I'm going to find the area of this kite, or this rhombus, I guess, and I'm going to take this triangle and I'm going to lump it off and I'm going to rotate it around and put it up here like this. Do you see that? Mm-hmm. And I'm going to do the same thing with the other side. I'm going to take this and I'm going to lump it off and I'm going to put it up here like this. And what I have left over is this shape, which is a what? Rectangle. And to find the area of a rectangle, you take the base times the height. Now, what is the base? What do they have the base labeled as? D1, which stands for diagonal 1, right? Okay, what's the height? What's this dimension right here? Half of D2, right? Like it's no longer the full D2 anymore. It's just half of the D2. So if I'm taking base times height, we're taking D1 times half of D2. Or their formula is 1/2 D1 D2. Yeah? 1/2 D1 D2. Okay? Same thing for this kite over here. If I take this chunk and lump it off, rotate it around and slap it up here, I have this guy. Whoop. If I take this one, lump it off, slap it up here, I have a rectangle where the base is D1 and the height is just half of D2, right? So the formula is 1/2 D1 D2. Okay, now, Luke this morning said, okay, does it matter which one you take half of? And I said, okay, let's do this. Let's say that this diagonal is 4 and this diagonal is 10, right? Let's do it. 1/2 of 4 times 10 versus 1/2 of 10 times 4. Okay, what's half of 4?
2.
2 times 10 is 20. What's half of 10? 5 times 4 is? It doesn't matter which one you do half of. Now, if you're looking at this first example right here, which one are you going to take half of? 8, right? I would put 8 in the first spot because half of 8 is easier than half of 15, correct? So half of 8 is 4 times 15. 60 meters squared. Okay? Next, B. I'm going really fast. Half of diagonal 1, diagonal 2. What's the first diagonal? What's the first diagonal? This one is, if we say that's our diagonal 1, that's actually 20 because 10 is only from here to here. You see how the markings are? Okay. Then what's the other diagonal? 24, right? So do you want to go half of 20 times 24 or half of 24 times 20? I'm going to go 20 just because half of 20 is 10 and 10 times 24 I can do in my head. What's 10 times 24? 240, and that's in feet squared. Good? I'm going really super fast, guys. All right, last question. One diagonal of a rhombus. Here's my rhombus. One diagonal of a rhombus is twice as long as the other one, okay? So we have a short diagonal, we have a long diagonal, and one of them is twice as long as the other, okay? So what do we label each of our diagonals as? If one is twice as long as the other.
1 is 2, whatever.
Yeah, so we need a variable. Let's call it D, okay? So let's label this guy as diagonal or D, right? What would this one be? Twice as long as that, right? 2D, right? So we have D and 2D, yeah? All right, to find the area, we do half
Why is that so funny?
of diagonal 1 times diagonal 2. Half of D times 2D, yeah? So,
169
yeah. Half and 2 are going to cancel out, right? Okay, so we have D squared equals 169, and then what? Take the square root, right? What's the square root of 169? 13. So one of the diagonals is 13. What's the other one? 26. That's the second diagonal. Yeah? Does that make sense? Because they're double. One is one length and one is double. Okay? Yeah. Then it has the summary. So parallelograms, base times height. Triangle is 1/2 base times height. Trapezoid is this guy. And rhombus and kite are this guy. So that's just a summary of all of the formulas. Okay? We will not take a chapter test over this. We will have these, though, on the semester test. But you will not need to memorize any of these formulas because we're going to write them on your review packet. Okay? Good? All right, so there's that. All on skills practice? All on skills practice?
And then
Evens on the other one. Yep. All in, you just know me too well, right? All on evens. Now these are shorter, I think, probably than the because you don't have to find perimeter, right?
Yeah.
You just have to find area. So these ones are actually a lot shorter than what 10-1 was. So there's that. Okay, good? All right, everybody said bye, Jake.
Bye.